let's look at factorizing quadratics where the coefficient of the squared term is equal to 1. So a quadratic expression is in the form ax squared plus bx plus c, where a, b, and c are constants and x is a variable. In other words, a, b, and c are some numbers or unknowns that don't change in value, whereas x does change in value. Suppose we had the brackets x plus 2 and x plus 3, and we expanded these brackets, then we would get the following. So x times x would give us x squared, then x times 3 would give us 3x, and then 2 times x would give us 2x, and 2 times 3 would give us 6. And so if we collected like terms, we would end up with x squared, and then 3x plus 2x gives us 5x plus 6. If we look at the quadratic expression that we have, and we look at the term in the middle, the coefficient of x here is equal to 5. And looking at the numbers within the brackets that we have, we see that there's a nice relationship between the two numbers here, 2 and 3, in that 2 plus 3 gives us 5. We also see that the number on the end here, 6, is equal to 2 multiplied by 3. And finally, the coefficient of the squared term here, so that's x squared, is equal to 1, since we only have one x squared within this quadratic expression. And so when we have a quadratic of this form, where the coefficient is equal to 1, which we don't need to necessarily write, since x squared is the same as 1x squared, then we can use the following method to factorize a quadratic in this form. So we look for two numbers that multiply to make 6 and add to make 5. And the way we find those two numbers is by thinking about the factors of the number we're trying to get after multiplying. So in this case, that's the 6. So we look for factors of 6 in pairs that multiply to make 6. So in other words, one pair would be 1 and 6, since 1 times 6 equals to 6. Another pair would be 2 and 3, since 2 times 3 equals to 6. Another condition that the pair of numbers needs to satisfy is that they need to add to make 5. And so in this case, we can consider different signs and then see which pair gives us 5 after adding the two numbers together. So in this case, if we look at 1 and 6, if we have both of these as positive, then 1 plus 6 gives us 7, which is not what we require since we need 5. If we took 1 to be negative, for instance, then minus 1 plus 6 is equal to 5, so that does work. But now minus 1 times 6 equals to minus 6, and our condition is that the two numbers need to multiply to make 6. We quickly repeat this process until we find the two numbers that we require. And so in this case, it should be fairly easy to spot that 2 plus 3 equals to 5, and 2 times 3 equals to 6. So the two numbers we require are 2 and 3. So finally, we would then write our answer as a pair of brackets with the first term in the first bracket as x, the second term in the first bracket as one of these numbers. So if we take 2 first, then we have x plus 2 in brackets, and our second bracket with the first term being x, and the second term in our second bracket being the second number. So in this case, positive 3. And so we see then that x squared plus 5x plus 6 factorized is equal to x plus 2 brackets x plus 3. Let's look at some more examples. So the first example says to factorize x squared minus 5x plus 4. So again, we look for two numbers that multiply to make 4 and two numbers that add to make minus 5. And so in this case, we need to look for pairs of factors of 4 that multiply to make 4. So if we start with 4, we have one pair as 1 and 4 and another pair as 2 and 2. So looking at the signs here, if 1 and 4 are both positive, 1 plus 4 gives us 5, but we require minus 5. Likewise, if 2 and 2 are both positive, 2 plus 2 gives us 4, but we require minus 5 when adding. So we know that both numbers cannot be positive. So if we try 1 as negative and 1 as positive, then we have -1 and 4. -1 plus 4 gives us 3. So that doesn't work. Likewise, if we had -4 and 1, then -4 plus 1 would give us -3. And again, that doesn't work. Likewise, if we have the 2's here, 2 and -2 added together gives us 0. So once we get the hang of this, we should be able to spot quite easily that -1 and -4 both add to make -5, and also both multiply to make 4. So the two numbers we require are -1 and -4. And so writing two brackets, we would have x and then one of the two numbers. So I'll write -1, and then another bracket with x and then the other number, which is -4. We can now quickly check to see that these two brackets do expand to make our quadratic expression here by expanding these out. So x times x gives us x squared, x times -4 gives us -4x, -1 times x gives us -x, -1 times -4 gives us +4. And collected like terms, we end up with x squared minus 5x plus 4. And so we see indeed that these two brackets are the correct brackets we require when factorizing this quadratic expression. Second example is to factorize x squared minus 2x minus 35. So again, we look for two numbers that multiply to make -35 and add to make -2. So we'll look at 35 and we'll look at the pairs of factors that multiply to give 35. So one pair would be 5 and 7. Another pair would be 35 and 1. And so looking at these pairs, we can clearly see then that there is no way that we can add 35 and 1, including different signs, to give us -2. So we know that we must have 5 and 7, and so 5 plus 7 gives us 12. That doesn't work in this scenario. So we require one of these numbers to be negative, and so in this case, if we make 7 negative, then we have 5 plus -7, which gives us -2, and 5 times -7, which gives us -35, which is what we require. Therefore, our two brackets would be x plus 5 and x minus 7. And if we were to expand these two brackets out, we would see we end up with x squared minus 2x minus 35. The next example is to factorize x squared minus 49. So looking at the general form for a quadratic expression, we see that we have an x squared term, and we also have a number on the end, but we don't have a term that has any x's only in it. And so therefore, we can rewrite this as x squared plus 0x, since there are no x's on their own in this quadratic, minus 49. So again, we repeat the process of looking for two numbers that multiply to make -49 and add to make 0. So we're looking for pairs of factors of -49. So we look at 49 first, and so we have one pair as 7 and 7, another pair as 1 and 49. You see then that the only way to add a pair of factors of 49 so that we end up with 0 is when we have -7 and +7. And so our bracket would end up being x plus 7, and another bracket would end up being x minus 7. And if we were to expand these out, we would get x squared minus 49. In this situation, we call this the difference of two squares. Since we have a difference, so that's the minus sign here, and we have two squares. The first term here is x squared, the second term here is 7 squared. And so two squares will always be in this form, where you have the same number or the same letter repeated with a positive and a negative sign. Last example here is x squared plus 100x. And so to factorize this, we see straight away that both of these terms have x in them, so we can factorize x out, and so we're left with, in brackets, x plus 100. And there is no other way that we can factorize this. So we have factorized this completely. In summary, when the coefficient of the squared term is equal to 1, when we have a quadratic, then we can use this method to factorize the quadratic.